Hello, my dears. We are going to work on day 7, more properties of logs. So, like before, I have our little red log property box. We're going to use those at any time that you see fit. Particularly number 4 comes into handy a lot. So, let's try. We're going to show it graphically as well. And let's get started. Okay, example 1, solve for x. 4 raised to the 5x plus 2 equals 70. I'm in exponential, I'm stuck, so let's go ahead and apply the log to both sides, which will help us pop that exponent to the front. You apply the log to both sides. I want to get x by itself. I notice I have this log 4 being multiplied, so I can divide that on both sides. I have log of 70 divided by log of 4. And then it's going to be order of operations. You're going to subtract 2 and then divide by 5. So you're going to have log of 70 divided by log of 4. That is being subtracted by 2, and everything is divided by 5. If you wanted to show more steps on that, you are more than welcome to. This would be the exact answer. If I asked you to approximate with your calculator, you should be able to get about, I don't know why I put 2 symbols, but you should be getting about 0.213. Now, if you're not able to get that, you need to make sure you have your parentheses around your log. You want to make sure your numerator is then divided by 5. So I'm going to show you how I would type it in case you weren't able to get that. So you would press log of 70, close the parenthesis, divided by log of 4, close the parenthesis. Just to be safe, I'm actually going to press enter here, then take away 2, press enter, so that's my numerator, divided by 5, and voila, that's my answer. If you are more confident with your calculator and you can put it as one big step, go for it, but in case you had any errors, this would be the best bet to do. Now we're going to look at this comparing to the graph. So if you wanted to see this graphically, I could have in my y1 in my calculator the left side, 4 raised to the 5x plus 2, and then on y2 my second line would be 70. I'm finding where those 2 points intersect. Notice they intersect right here at 0.213, which is exactly what I found algebraically. So all it is setting this curve, which is the pink curve, equal to y equals 70, which is the blue line. Now, moving on to something new is change of base. So some calculators have this change of base ability to it. Not all. So in order to be equitable, we're going to show how to do change of base, and this is what I want all of you to do based on if your calculator does apply it or not. We're going to all do change of base together. Well, the reason why we need change of base is because normally log is base 10, and that's, for most of us, the only way we can type it in the calculator. We can't change the base on a calculator from 10. You're going to use this formula. If you look at it, notice when they're equal, the base of A becomes the argument in the denominator. Your x is the argument, is going to actually equal the argument of the numerator. So look at this quick example. It is log base 2 of 3. I cannot type that in my calculator. So I'm going to do the change of base. The base of 2 becomes my argument in the bottom. The 3, which was the argument in my normal log, becomes the same argument in the numerator. They now will have the same base. They'll be base 10. You can either write it in terms of log or ln. They will be equal, and you're able to put that in your calculator. Let's try one together. So express log base 2 of 5 in terms of base 10 logs. So if you understand the formula, by all means jump to it. If not, I'm going to show you where it comes from. The hint, write an exponential. Shocker. So I'm going to have 2 raised to the x equals my argument of 5. I'm stuck, so I'm going to apply the log to both sides, which pops that exponent in the front. I'm going to undo the multiplication with division, and look at that. I now have log of 5 over log of 2. When there's no actual log written, you know the base is 10. Okay, so that's where it comes from. You just change the base from 2 to both having 10. If you want to just use the formula, by all means do that. You have log 2 of 5. Well, when you change of base, you're going to have both logs have base of 10. Your base in the original becomes the argument in the denominator. And then the 5 becomes the argument in the numerator. Notice they match. And you just did change of base. Okay, you will need to show that. You may not type in log base 2 of 5 into your calculator. Not possible. One final example. Let's try this together. We have log base 2 of 10 times log base 10 of 2. You cannot multiply these because they don't have the same base. They're not like terms. You can go ahead and use your formula, or I'll show you where the formula comes from again. Your log base 2 of 10, I'm going to focus just here. I'm going to rewrite that as 2 to the x equals 10. I'm going to apply the log to both sides in order to get the x in front. Property number 4. Looking good so far. We know that log of 10 is just 1, again from our property sheet. So then I can get x equals 1 over log of 2. Now I'm going to do the same thing for the purple. Getting it into exponential would be 10 to the y. I'm just changing the letters so we don't get confused. Would equal 2. I'm going to still apply the log to both sides in order to get that exponent in front. Again, a log of 10. We love those because they cancel to 1. And in this case, you have y equals log of 2. Well, the whole time you were multiplying these two, so in a way you were multiplying x times y. That's what this problem right here is saying based on what letters we used. So you really have 1 over log base 2 times log, sorry, not base 2, argument 2, log of 2. Notice they are the same thing. I can even put this over 1 if you want. See, they will cancel, and they will give you 1. If you wanted to just do the change of base formula from the beginning, it would have got you the same answer, but it's important to know where it came from. Finally, I have a bunch of errors to avoid. So please take a look at these. These are common errors. Be familiar with these. And if you're making some errors, maybe check. Maybe these are the errors you're making and you want to clear them up. If you have any questions, please bring them to class. But this is day 7 notes.